video is a review of the Edgenuity lesson multiplying monomials and binomials. So in the video, they talk about special patterns when you multiply binomials. So the first one, the difference of squares, that's where if you have a plus b times a minus b. So essentially, the first and the last thing are the same, just their sign in the middle is different. So it'd be like x plus 2, x minus 2. When you multiply this out, what you end up getting is just the first thing squared minus the second thing squared. So I know that this answer is going to be x squared minus 2 squared, which is 4. The reason that happens is when you multiply, so if we go here, we'll get x squared, but then when we do the outside, we get, here, I'll just do it. So first, outside, so x times negative 2 is negative 2x. Inside, 2 times x is positive 2x. Last, 2 times negative 2 is negative 4. And what happens is every single time these parts in the middle will cancel each other out. The important thing to note is that this has to be subtraction. That's why it's called a difference of squares. There is no pattern for a sum of squares, so it has to be a minus sign in the middle. Now, if you have perfect squares, so for the exact same thing times itself, so like x plus 4 times x plus 4, exactly the same thing. This is how it will multiply out. You would get, so we are doing the positive, so it'd be x squared plus 2 times x times 4 plus 4 squared. So 2 times x times 4 is 8x. You just multiply the numbers. Plus 4 squared is 16 is how that multiplies out. And if these special patterns confuse you, just do it the way that they show you in the video. Just write it out and multiply it. It still gets you to the same answer. These are just shortcuts. So if the shortcut confuses you, don't use it. So when in the video he multiplies using the distributive property, some of you may have heard the term FOIL before. That's what I tend to use. You can use whatever gets you the right answer. So the way FOIL works, F stands for first. So you multiply the first thing in each binomial. So those two. So if I multiply the numbers, 5 times 3 is 15. R times R is R squared. Oops, I wrote that too close. Oh well. Next, the O stands for outside. So you multiply the outermost parts. So 5r times negative 4. 5r times negative 4 is negative 20r. You should multiply the numbers, and then this one doesn't have a variable on it. The I stands for inside. So you multiply the innermost 2. 2 times 3r is positive 6r. And then last, you multiply the last things in each binomial. So positive 2 times negative 4 is negative 8. And then you combine your like terms in the middle. So we end up with 15r squared. Negative 20 plus 6 is negative 14r minus 8. On this one, we have a monomial times a binomial. So we're just going to distribute this 3x to both parts. 3x times x is 3x squared. 3x times negative 4 is negative 12x. And that's all we can do there. There are no like terms. On this one, again, you can do the distributive property if you want, or you can FOIL. If you do the distributive property, you just multiply the 6x. Actually, I'll do this one with the distributive property so you see both. So I would distribute the 6x to both parts here. So 6x times negative 4x is negative 24x squared. And then 6x times negative 3 is negative 18x. Then you have to distribute the second part. So I'm going to take the negative 2 and distribute it to both over here. So negative 2 times negative 4x is positive 8x. Negative 2 times negative 3 is positive 6. And then again, combine those like terms in the middle. So negative 18 plus 8 is negative 10x plus 6. There are quite a few questions in the quiz section that ask you to identify whether or not you have any special products. So when you're looking for the difference of squares or perfect squares, notice how both of them have the word squares in them, difference of squares and perfect squares. So you need to be looking for numbers that are perfect squares. So 1, 4, 9, 16, 25, so on and so forth. So this is just a list of 1 squared, 2 squared, 3 squared, 4 squared. You need to have those type of numbers in there for it to be a special product. So like these ones, I can tell they're difference of squares because they're all perfect squares in there, and they are subtraction. It has to be subtraction for it to be a difference of squares. Also, on a difference of squares, there's only 2 parts. Only 2 parts. On perfect squares, there are 3 terms. The number in the middle will not be a perfect square there, though. You need to look, you're paying attention to these numbers, or these terms, I mean, the first and the last term. And there will be 3 terms for it to be a perfect square.